Hey everyone. Today we'll be going through the trig formula for triangle area. Now, as you know, what you've learned probably from year 7, 8, or whenever, maybe in primary school even, right? The the area formula for a triangle is half base times height. And that's a bit unusual, don't you think? Because height is not a side length of a triangle. Except, of course, when it's a right triangle. But height was the line perpendicular to the base. And that is not something you usually think of. That really comes as a result of that's we really use it because of the fact that we can construct rectangles for it from this. But height's not like a standard measure of a triangle. You really care about the side lengths more. So today we'll learn about a formula that will help us figure out the area just from two side lengths and an angle. Anyway, I'm not going to reveal the formula right now because I think it's better to take a look at the motivational problem. Let's say we knew, okay, here's a motivational problem. Find the area of ABC. With this little box around like this, the box implies area, right? ABC is the triangle, you put a box around it, that's the area of the triangle. You're really trying to find the area of triangle ABC. That's what this means. Area of triangle ABC. So, how do we find this area? Actually, before that, I need more information. Sorry. You need, like I said before, for this formula, you need, so this is 6, this is 40 degrees. And in fact, once you learn the formula, you don't even need to do much work. But let's actually do this without the formula. And that is to actually go back to our original definition of area, which is half times base times height. But we don't have the height right now. So what do? We construct the height. We just draw this line. Or we could also draw this one. Both work, but let's just work with this for now. Let's call this point H. Trying to find this height. So if we knew what the height was, right? If we knew what the height was, we could find the area pretty easily. It's half times 5 times by, which 5 is the base, and then height would be AH. So whatever the length of AH. Can we find AH? Well, if you've been watching any of the motivation problems for cosine rule and sine rule, you know it's pretty easy to find this, right? The idea is just, this is a right triangle, which we have a side length and an angle, so we can use trig ratios to find this. So in particular, this is, this is opposite, this is the hypotenuse, is known, so we want sine. In particular, sine 40 is the opposite side, which is AH, over the hypotenuse, which is 6. So AH equals 6 sine 40. And you plug this into your calculator, and you should end up with, oh, a second, 3.8567. And the area would equal, haha, 67. But anyway, area would equal half times 5, which is the base, times the height, which is 3.8567, which is 9.6418. And that is the area of this triangle. Now, just like the motivational problem for this, we had to come up with some construction, right? And while this construction was really nice and it will be really useful, because when we actually do the proof for the formula, be doing this construction, it is a bit time consuming. So we can actually use this formula. And the formula is area is half times AB times sine C, where C is the angle between A and B. Well, this is very similar notation to the cosine rule, where C would be the angle opposite side like C, which means the other two sides, and C is not in the formula, so that means the two sides next to it are the ones in the formula. That would mean that that means we can solve this question really easily using this formula. So immediately go, area would be equal to just half times 5 times 6 times sine 40. And that would, again, if you plug this in, this is 6 times 40 times half times 5. So it's the exact same thing as before. So when you plug it into a calculator, you'll get 9.6418 again. Right, so that's our answer. As you can see, this formula makes our life a lot easier. So again, the basic application of this is to solve, right, to find area. So we can have, I don't know, let's say another triangle, 4, 7, and this is maybe, let's say it's 33 degrees. You can find the area of this quite easily. It's just half times 4 times 7 times sine 33 degrees, which will be 14 times sine 33, which should be about 7.63 to 2 decimals. Let's go a bit further. Let's go 7.6250. Oh no, 49. And then we keep, but we can also use the area to find the a side length or an angle. Let's say we know the area of a triangle. Let's do something else. Call this x. Let's call this 53 degrees. We know area of, let's actually do the proper notation for area. So the area is, let's say it's about 8.7. Question is to find x. How do we find x? Well, it's quite simple. Just do the formula, which says area equals half a times b times sine of c. The area is 8.7. 8.7 equals half. And let's say let's call ax. Let's let this be a and this be b. So it's times x times 5 times sine 53. And you can rearrange for this quite easily. just algebra. You want to make x the subject, so you multiply both sides by 2, so it's 17.4 is 5x sine 53. You divide both sides by 5. Just keep doing it's basic algebra. You should be relatively comfortable with this at this point. If you're not, think of this as a good opportunity to practice. And x would be 3.48 over sine 53 degrees, which is 4.3574. So that's the first application. A more interesting application could be something along the lines of, let me try to construct a question. Okay. Let's say we're asked to find area of this triangle. This is a more complex application, and really, whenever I say it's a more complex application, I'll be honest. Most high school like challenging problems, this would be considered challenge, right? I'll give you a little bit of a secret. A lot of the time, it's not that really that challenging. All it is they just combine your concept, which will be current concept. Let's do a different color. Plus another concept. That's all it is. And you'll see what the other concept is as we solve this. But a lot of the time, I'm not saying this is not a general rule. Don't get me wrong. This is not hard problems all the time, right? Like I'm in uni right now, and a lot of the harder problems are much more structural. But in high school, a lot of hard problems are just this. Look for the other concept. Still not easy, don't get me wrong, but there's a little bit of a trick for you to make it a bit easier. So let's think of it like this. Let's try to apply the formula first. Try formula. And you probably see the problem, right? Problem is, we try to apply the formula, which is half AB sine C. I think you can probably think of this as C because there's a side close right next to it. But the point though is we're missing a side, right? Let's call the side X, let's say. The area would be half times 5 times X times sine 57. And well, we don't know X, problem. We don't know X. Yes. But the thing is, if we knew X, we are done. Similarly, you could actually try this with Y, because this angle is quite easy to find. It's 80. Angle times 180. And it's the exact same thing if you try to solve for Y. But actually, let's fill this in. This is 80. It's going to help us out. And that's quite easy. I think whenever you know two angles in a triangle, you should immediately fill in the third because it's trivial to find that. Yeah, so how do we find X? So is the question. And here's the thing. Just think back to original problems. Can I use like sine rule or cosine rule? Well, cosine rule requires two sides to be known and an angle, right? So cosine rule, here's the thing. Cosine rule has three sides. Ooh, sorry, I'm using terrible colors. Yeah. Cosine rule has three sides and one angle in it. So realistically, since every equation can only have one variable to solve for, like you can only have one of them be unknown to actually solve for it. So you can only really remove one side. So if there's still need two sides and one angle at worst, and we really only have one side, the cosine rule doesn't work. Instead, we should use sine rule. And why is that? Well, because we know the ratio for this side. We know that 5 over sine 43 is the same as the ratio of x over sine 80. So we can find x pretty easily. Now we're basically done, right? We find x, and we plug that into here, and we are done. So to find x, you multiply both sides by sine 80. And you solve for that. Actually, I'm going to leave it as it is. You can plug this into your calculator to get it, but I'm going to leave it. And then now finding the area is quite simple. It's half times 5 times x, which is 5 sine 80 over sine 43 times sine 57. This might look ugly, but all of these are all numbers, right? Sine 80 is a number, sine 43 is a number. So I think personally I prefer this, but if this gets overwhelming, feel free to if this is overwhelming, I think finding this value early can be helpful, but I think learning to deal with this sort of expression is also not a bad skill to learn. You plug this into your calc and you should end up with 15.1380. And that's it. That's the area of this triangle. So yeah, that's what a challenging application would be like, combining the area formula with one other concept. Okay, and to finish off the video, we'll do the proof, right? Why is this true? So the proof, again, is very similar to this motivational problem. A lot of the time, like, this motivational problem might seem pointless at the start, but proof's basically identical, right? All you do is you replace all of the known values with an unknown, with unknowns, but you pretend you know them. You know the unknowns. So you know A, B, and capital C, and angle C. And the unknown is area, or slash the goal. You want to find the area relative to these known, like these fake known values, I guess. And the area would therefore, the way we find this, again, we can't use the formula. We're trying to prove the formula is true, so we have to do it some other way. The other way we know is with the basic height formula. So let's create this altitude. And let's denote it h. So if we find h, area would be equal to half times base times h. But again, we want in terms of a, b, and c, not in terms of h. So how do we find h? Well, we do trig. Particular, this is the side opposite. This is the hypotenuse. So sine of c would equal the opposite, which is the height, over the hypotenuse, which is a. That would mean h would equal a times sine c. I can directly replace the h with a times sine c, which is half ab sine c, just as we had in the formula. And then we're done. And that is the proof. Do you see how the ideas are very similar? So I really think this motivational problem is the foundation. And actually, if you wanted to, let's say you forgot all the formulas. Let's say somehow in the test, you're not allowed the formulas. And unfortunately, you've forgotten the formula. Not ideal, but can happen. You never know how our memory works. Memory can forget things. And in that case, well, you can actually solve this question even through this as well. You can try to find this height even. Because you know the base, find this height, and figure it out. And actually, you can probably, it's not terrible to do. You can try to figure it out from here. No, that's actually not going to work. I think you might need to create this. And then you can figure things out from here. So yeah, but the point is, I'm not going to go through that, but the idea is you can use the technique, not just the result. The technique itself is very useful. So knowing this technique can actually come to save you in hard problems. So please practice the technique itself of like creating altitudes rather than just knowing the formulas, because being someone who memorizes formulas well isn't as important as understanding the underlying logic behind it. Anyway, that's it for the video. Bye.